Hey everyone, this is demo of Irontools, a suite of Flink extensions that make Flink more efficient and unlock new use cases. Um, we're gonna be looking at Iron functions. This extension allows you to author business logic or any code to execute in different languages like TypeScript, Rust, Golang, so languages that are not typically supported by Flink. And we're going to be doing this thanks to WebAssembly, fast and secure WebAssembly runtime. And this demo specifically is focused on DataStream API. Please check the other video for the table and SQL API. So I have a typical Java Flink application using Flink 120, and this application reads data from Kafka. The data is in Avro format, so it serializes the data, and then currently it simply prints it out. So we can run it, see some output, and we'll explore the data in a second. So as you can see, it's not a lot, it's about 100 records, and the data looks like this. So it's sort of IoT data where we have timestamp, ID version, event time as top level fields, and then we have the actual payload as data, which is JSON encoded. And as you can see, it's an array of payloads with device IDs, some values gathered for that device, some additional model tags information. And so our goal is to create a TypeScript function that's going to parse this payload and it's going to flatten it. So we're interested in getting a row per device value. As you can see right now, they all batched together in this JSON array, and we're going to be flattening this array and sort of unnesting it. So we want to get a row for each device measurement at the end. Okay, so I showed you this is a typical Flink application, and now we're going to be creating an iron function using the provided iron function CLI. So iron function CLI has commands, so we're interested in a generate command right now. The generate command creates project scaffolding, so we just need to provide a name, language, and the output path if it's not current. So let's go to source main. We're going to create a TypeScript folder, and in this folder we're going to create this project called telemetry parsing using TypeScript language. Let's generate that. It's very quick. As you can see, it's a typical NPM project with TypeScript support. Let's explore here. We have, all the standard package JSON, TypeScript config, and then we have our main TypeScript file and also the README. So the README tells you to install Xtism JavaScript compiler. So Xtism is a great WebAssembly framework that Irontools uses to interact with WebAssembly. And you'll need to install this JavaScript compiler right now. It's not provided by the CLI yet, but in future it's going to be all in the same CLI. And then simply run the npm install command. So I already have the compiler, but I do need to run the npm install to get the iron functions SDK as a dependency. The package JSON looks like this. It's fairly bare bone. Really just need one dependency and then a few dev dependencies. So this is what our file looks like again. And our goal is to implement this process function. It has to be exported. And in order to interact with Flink ecosystem, Iron Functions SDK provides you Flink IO read and Flink IO write methods. Now, this is a TypeScript project, and you can do anything you want. You can bring dependencies, you can configure it, you can create multiple files, multiple folders, you can use classes, interface, like anything that you want works here. The only requirement is if you bring external dependencies, if you install something, right now the runtime does not support node modules, so node APIs, node modules. Stick to the browser version of JavaScript or TypeScript, and you can definitely polyfill some of those node modules, not all of them of course, and by design, you're not supposed to interact with the file system or some system calls. WebAssembly just doesn't allow you to do that because WebAssembly runs in a container in a way, right? It's sort of isolated. Anyway, we can do a lot of things without those node modules, and here we're just interested in simple parsing, right? And let's start by implementing our input, right? Because we are currently operating on any object, which is not great, right? We are in TypeScript world, right? So let's start with the class. I'll just call it input, and we're gonna describe this class according to the payloads that we have in Kafka, right? So it's simply ID, timestamp, and then we had event type, version, and the data payload, right, which is currently a simple string, and the timestamp is actually not a string, it's a big int, right? So we're going to be using that. So now we define our input class. We're gonna use that, and currently this is just a knob, right? It's going to pass the input to the output. But let's actually try running this, right? So we need to run this npm run build command, which uses that xtism plugin to compile. So now in our dist folder we'll have the compiled JavaScript file, but also the WebAssembly runtime one. And xtism also has a great CLI, which allows you to run different functions from the CLI. So for example, this one basically is a way to test this process function that we already have, and we're going to be passing this input, which is a valid JSON. It's not a complete JSON, but let's see, it does work, right? So it does just simply print the input. And if you want to test something more realistic, right, I have this snippet here, which is a complete Kafka payload in JSON, right? So this is what we're going to be getting from Irontools, JSON payload. And let me just so if we pipe it to JQ, we're gonna get the single record with the data payload, right? So this is what we're gonna be flattening. Okay, so let's go back and let's implement the rest of the logic. So now, because we're gonna be flattening this, we're gonna be returning an array from this function, right? So our result is simply is an array. Let me clean this up. So this is an array, and first of all, we wanna parse the data payload, and we've seen this is an array, right? So we're expecting an array, and then we're gonna be iterating this array. So for each payload, we're gonna be doing something, right? So first of all, if you look at the structure, you can see that the device ID and model, they are in the nested JSON payload, right? So first, let's create device ID that is simply device.id, right? The same for the model. And we also have device tags. So to do something interesting, I'm just gonna basically join them with a comma, let's say, to start, right? And then our final payload, it's not gonna have the data field, right? Because we are removing it. So let's kind of deconstruct it, right? So we're just gonna get rid of data, and all the other fields are gonna be this variable. Right, and so now we can form our final payload, which is going to be the device ID, device model and the tags. Then the value, right? This is the most important part. We're dealing with telemetry, so we need to extract this value. And then finally all the other fields, we'll just put them back, right? So this payload, simply push it to the results array, and we write it out. Okay, so now let's compile again, build again, and if we run our test payload, so instead of getting one result, we now get 4, and as you can see, we have the device ID, model, tags, the value here, but the ID and timestamp and the version, yeah, all the other fields stay the same. So this is exactly what we need. Now we have this WebAssembly file, and of course you can package it very differently. You can put it in your Docker image or jar file, or you can inject it in the build time, or you can inject it in runtime. Basically, Iron functions just need to get this file somehow. And the simplest way, if you're just starting, is just put it in the resources folder, right? So I created this wasm directory, and I'm going to copy the wasm file as demo telemetry.wasm, so it's here. And now, going back to Flink, this is how I read this file. And because we are defining a schema on the output that's different, we need to define our data type that's different. So we currently using row type, row and row data, just because we're going to be integrating with a table API, for example, right? So this is the schemas we're dealing with, and if we were to keep the same schema, the same input schema, we don't need to change anything. We don't need to define anything for the output, but yeah, this is different. So define that, and we define a new operation in our topology using the process method, and we are providing this iron wasm row function. So this is what's coming from the iron functions dependency, and you simply need to provide the input type information or input data type depending on what format you're using for your data, the output data type or the output type info. Right now it's the transformed one, but again, if we were to use the same schema, simply maybe to enrich one of the fields, we don't need to define anything here. Because we are returning the array from the function, we need to unnest this output, and we're simply pointing to this wasm resource file that we have, and we're going to be printing the results as well. So now if I run this, instead of getting 100 records with with the JSON payload, we're going to be getting a lot of we're going to be getting more records with the data flattened, right? So for example, we can see here for this ID, yeah, we have several records with the values and the models and the device IDs all nicely flattened. So this is just a little example of what you can do with Iron functions. As I mentioned before, you can use any TypeScript or JavaScript for that matter with any dependency that is a browser that uses the browser's API and not the node one. That's the only requirement, and you can build anything you want with this, and there's obviously going to be support for Rust, Golang, and some other languages. That's pretty much it. Thank you for watching, and please contact us if you're interested.